In this presentation for descriptive inorganic chemistry, we're looking at lecture 15, supplement, spectator ions. In this case, we're going to be looking at the chloride, which we could include bromide in that case, iodide in that case, because they're all from strong acids, i.e. they're conjugates. So if we assume that chloride ion acts as a Lewis base or indirect Arrhenius base, that produces hydroxide ion, we might model it as the following. Chloride ion hydrolyzes the water molecule to create a basic solution, i.e. the hydroxide ion, which is the strongest base that is present in water, plus the ion pair HCl. And we're assuming that HCl is associated. So the question then is this realistic? Well, if we look at the right-hand side, we see hydroxide and HCl. That's a strong base, that's a strong acid. So the equilibrium arrow should really essentially lie back to the reactant side, and the product side might have an arrow of that extent. Kind of silly, but kind of gets the point across. So continuing with our modeling, as we've done before with the sodium ion as a spectator ion, we could look at chloride ion being a base, which is related to the Kw divided by the Ka for HCl, its conjugate in this case, which we're suggesting it's 10 to the minus 14 for the Kw of water at 298 K. And based on our leveling discussion we've had before, we suggested that the Ka for HCl is 10 to the 4th. This suggests that the Kb for chloride ion as a base is 10 to the minus 18, which in comparison to water, chloride ion is now considered a weaker base than water itself. Kind of fits our model. So we got two suggestions there. So how do we arrive at this? Can we check this idea right here? Yeah, let's take a look at that real quick without doing a lot of calculations. So let's go back to that equation, chloride ion, and I'm leaving off the aqueous. I'll put them in. Plus water. We're suggesting that the left-hand side is favored. Get hydroxide, aqueous, plus the HCl, aqueous. And we suggested the Kb for chloride ion was in fact 10 to the minus 18. And we said it was related to the Kw divided by the Ka for HCl, which is the conjugate of the chloride ion. So, and we said that the Kw is hydroxide ion times hydrogen ion. And then my Ka, let's look at that. The Ka for HCl is related to the following reaction. I got HCl, aqueous, strong acid. Products are preferred, which are the ions, hydrogen ion plus chloride ion. So if you look at the reverse, or the reciprocal, we would have 1 over the Ka, which then we're looking at hydrogen ion, aqueous, plus chloride ion, aqueous, giving us our HCl, aqueous. So if we look at products of reactants, relating it back to the reciprocal here, we're using this guy. So products reactants would be HCl concentration divided by the hydrogen ion concentration times the chloride ion concentration. And if we notice, which is nice about this modeling, which is not the best, but it works, that the hydrogen ion cancels out, and we in fact get the equilibrium constant for this process. Here we got hydroxide times HCl concentration divided by the chloride ion concentration. Sometimes we choose models that really get across some ideas. Well, we could talk about some other things. The sulfate ion as a spectator is a little bit more involved. You can take a look at the handout that's related to this lecture 15 supplement. Thank you very much.